Hi guys, so for today, we're going to solve the second problem, which involves the tension and acceleration of the Atwood's machine, but it's a different setup compared to the first problem. So we have this setup, which has 6 kilograms and 3 kilograms for mass 2. So let me just pull up my tools. We have this. Okay, so again, I am not trying to have a perfect diagram here. I am just trying to have this. Okay, so I have mass 2 here, and this is mass 1. The mass 2 is 3 kilograms and mass 1 is 6 kilograms. You have to understand that there is no given for the coefficient of friction. That means that you can just neglect the friction for the mass 2 here. And at the same time, you can observe that the weight for mass 1 is greater than the weight for mass 2. Since it's frictionless, then that means that it will just go in a clockwise direction, and this one will go to the right and this one will go down. I believe that you already know that the orientation is up and right is positive for the y and x axis respectively, and negative is for the left and negative is for the y. Negative is going down for x and y respectively. All right, so we have this is moving in a clockwise direction. Okay, my pen is acting up. Oh my, what is happening? Okay, this is moving in a clockwise direction. So with this, we can have the free body diagram of mass 2. So the free body diagram of mass 2 is tension is equal to M2A. You will notice that this is positive because it's going to the right. And at the same time, you don't have friction, so you don't write tension minus friction. It's just nothing here. And then afterwards, we have the forces acting here. We have tension and we have the weight. So that means that which is also equal to mg, m1g. So this is going to be tension minus m1g is equal to negative m1a. So with this, we can have m2a for the tension, and this tension is equal to m1g minus m1a. Rearranging it, we will have this tension, and since the tension is just the same, we can equate it. Tension m2a is equal to m1g minus m1a. Rearranging it and combining like terms, I will have m1a plus m2a is equal to m1g. Factor acceleration, I will have acceleration is equal to m1 plus m2 is equal to m1g. Divide both sides by m1 plus m2, I will have acceleration is equal to m1g over m1 plus m2. I already know the mass 1, which is 6 kilograms, so that means that A is equal to 6 times 9.8 over 9. The answer here is 6.53 meters per second squared. So I already have the acceleration, but I need to determine the tension. The tension here, I can use the first equation, or I may like to use the second equation, but the first equation looks easier because it is easier. So the tension is equal to, the mass 2 is 3 times 6.53. So the answer for that one is gonna be 19.6 newtons. So with this problem, you already have the acceleration and tension.